Hello everyone, so welcome to this new videos. In our previous lectures, we already talked about how we can use the hypothesis test to test our null hypothesis about our mean of normal distribution when the variance is known or unknown. So in this video, we will continue on our materials of hypothesis test. So in this video, we will work on the hypothesis test on a population proportion. So before we introduce this style of the hypothesis, let us review about the materials of what is a population proportion. So when we talk about a population proportion, we always talk about a random variable, or the population follows a binomial distribution. So generally here we denote this by x is a bin with a total size as n, and p is our proportion. So here in this case, actually we can understand p as the probability of our success. So when we do the point estimator, what is a point estimator of our population proportion? So this is denoted by p hat. So p hat is we use the number of our success in the sample size divided by the whole numbers of our observations in our sample. So in this one, we can use this p hat to estimate our population proportion. But please remember, we only use this one when n is large enough. So of course, this large enough, it depends on our require of the occurrence. So in our case, we always use if the n times p is larger than 5 and n times 1 minus p is also larger than 5. So in this case, we will think n is large enough. So this is about what we have. So when we have this n is large enough, what we have is we will have our x is follows normal distribution, and this normal distribution is have the mean as np, and the variance standard variance is np times 1 minus p. So that's what we have. And the basic idea is when n is large enough, we can use this central limited theorem to have this one. So now what we want to do in this video is we want to introduce a hypothesis test about our population proportion. So for our hypothesis test, we already talked a lot about this. For the hypothesis test, we always have a null hypothesis. So this is we denoted by H0. So in this part, this null hypothesis is still an equation. So we will have the equation as p equal p0. So here p0 is our assumption of the true value of our population proportion. And then for our alternative hypothesis, the H1, here we also have three different cases for our alternative hypothesis. So again, the first one is still a two-side test. So based on this one, so we will have an inequation for our first case. So this is p is not equal our p0. And then the second and third one is two one-side test. So here we still use this p greater than p0 for our second case, and then for the last one is we have the p is smaller than p0. So this is our, you can say, assumption of our population proportion, or you say the hypothesis of our population proportion. So then what we will do is, by the idea of the hypothesis, we will still to select one test statistics. So what the test statistic we will choose? So here we will still choose our z test. So our equation of our z0, this test statistic, is for the numerator is our p hat minus our assumption p0, and the denominator is a square root. So it's a square root of a fraction. So here the numerator is p0 times parentheses 1 minus p0, and this is divided by n. So by our knowledge of our x, when n is large enough, we know x is also a normal distribution with mean as np and variance as np1 minus p. So based on this, we know our z statistics. Actually here, this one is a standard normal distribution. So we have the mean of this distribution is 0 and the variance is 1. So based on this one, similar to our test of the mean for a normal distribution, what we can do here is we can have the conditions of when will we reject our null hypothesis H0 for these three alternative hypotheses. So I list these three cases here as this table. So here we can say here we have three rows in our table. So each of them for the first row is a case for the two sides hypothesis test. So we have this our alternative hypothesis H1 is in equation P not equal P0, and the second and the next row is about the second case P is greater than P0 is a one-side test. And the last one is P is smaller than P0. This is our other one-side test. So similar to our previous hypothesis test about mean of the normal distribution, we also have two ways to reject our null hypothesis H0. So the first one is if we look at our p-value. So here we have this p-value. For the first case, the two-sides case, if we have this p-value is smaller than our alpha, then we have this, because the two sides test, we have work on the two-tail, right? And because the normal distribution, we have the symmetric property of the normal distribution. So that's why here we will have this probability, p-value, the probability here is 2 times the probability of our capital Z0 greater than the absolute value of our small z0. So this is the way we can compute our p-value here. And then for the second case, this is about the p is greater than p0. So in this case, we can compute our p-value as the probability of our capital Z0 greater than small z0. And the last one is p smaller than p0. So on this case, we will work on the left tile. So we have the capital Z0 is smaller than small z0. So when the p-value is smaller than our alpha, we can reject our H0. And another way to decide whether we can reject our H0 is look at the critical region. So here, this critical region, we can have fun for the first case because this is a two-side test. So if we have our absolute value of our Z0 is greater than Z alpha over 2. So we have alpha over 2 because this is two-side test. So we will have this one alpha over 2. And then for the second one, we have the Z0 is greater than Z alpha. So now we work on the right tile. So that's why we have this equation. And then for the left tile, which means the p smaller than p0, we will have our critical region is Z0 smaller than negative Z alpha. So this is a table for how we can do the hypothesis test of a population proportion. So now next, let me give some examples about this part to explain how we can do the step by step to finish the hypothesis test. So now let's look at this example. So here we have a company which who is claim that 90% of their employee are satisfied or customers are satisfied about their service. So how they do this conclusion? Because they take a survey of 80 persons, and then they find among these 80 persons, 65 of them is satisfied about their service. And then the question is, for a given significance level, alpha equals 0.01, and we want to know the claim is correct or not. So here for this question, so what we want to check is we want to check the claim is correct or not. In other words, it means we want to check our population proportion is equal 90% or not. And here, so far for this question, in fact, what we have is, if we want to work on this one, the first thing is we need to write down about our null hypothesis. So what we should write is, for our H0, the H0 is our P is equal 90%, or in other words, it means our P is equal 0.9. And then for our H1, of course, for our H1, we have three different ways to write our H1. But here, because this question, for our P, this is about 90% satisfies their service or not. So here what we should do is, for our H1, in fact here we are more care about, look like this. So we will have this equation, and by the calculator we will get a final answer for this. Z0 is negative 2.24. So now what we need to do is we need to work on the our one-side test, and because we have the alpha is equal 0.01, so then by this one we can find what is our Z alpha. So this Z alpha is our Z sub 0.01, and then we know this is a value between our number as this one. So this one is, we use the table of the standard normal distribution. We can find our Z sub 0.01 is a number between negative 2.33 and negative 2.32. We know this number for sure will smaller than our Z0, negative 2.24. So here, because we have our Z alpha is smaller than our Z0, we can give the conclusion. So our conclusion is we cannot, or we fail to reject our H0. So in other words, it means the claim, the original claim is correct. So the company claim they have 90% of people are satisfied with their service. This conclusion is correct. So next one, let us introduce what's the type 2 error, and then if we given a type 2 error, how we can choose the sample size to get this our test will have acceptable type 2 error with a given alpha. So for the first one, what is a type 2 error? We already talked this several times in our previous lectures. So type 2 error is if we say our H0, the null hypothesis, is not correct, but we still accept it. So in this case, it means if our P is not equal our P0, but we still think this is true. So in this case, if we look at our test statistic Z0, we will have, we know this Z0 is not a standard normal distribution. So in this one, what we will do is similar to our previous lecture. We will assume another value for the true value of our P, the population proportion. So here we denote this by our P prime. So by this one, because we work on the H1 as a P smaller than P0, so here our true value P prime should smaller than our P0. So because now P prime is a true value of our population proportion, we will have this new statistic P hat minus P prime divided by the square root of P prime times the parenthesis 1 minus P prime parenthesis divided by N. This one is a standard normal distribution. So based on this one, if we want to compute our beta, or in other words, the probability of our type 2 error, so we will get this equation is equal to the probability of our z0 smaller than z alpha. So when we plug in our definition of z0, we will have the second equation, this probability. And then with some computing, we will have the final one. So this is equal, beta is equal to the probability of our p hat smaller than this equation, p naught plus z alpha times this square root. So now what we do is we want to compute this probability. So what we should do is we should always convert this to a standard normal distribution. So what we know is we know the new test statistic when we define this P prime is standard normal distribution. So now we will translate this to a standard normal distribution. So we will have this long equation. When we change it to a standard normal distribution, we will still use z to denote it by our random variable. So this will become the probability of our z is smaller than this complicated equation. So for the numerator is as our original numerator, the p0 plus the alpha times the square root, and now minus the p prime. And then for the denominator, this denominator is the square root of p prime times parenthesis 1 minus p prime parenthesis divided by n. And all of this is in this second square root. So now what we have is here actually for all the equations after our smaller equation, we can denote this by our z beta. And this is our negative of our z beta. So here for this negative z beta, what we will have is now we can get an equation for our sample size. So here this sample size is look like this. So I will start a new page of this one. So here we will have this n is equal to the square of a complicated equation. So inside the square, this is our z alpha times a square root about our p0 plus the beta times a square root of our p prime. And then the denominator is use our p0 minus our p prime. So this is our formula for n when we given the alpha, the probability of type 1 error, and given the beta, the probability of type 2 error. So now this is the equation how we can choose a sample size when we require we will give satisfies accepted type 2 error, probability of type 2 error for a given type 1 error. So this is for one side test, and this is same for both one side tests. And then for two-side tests, the only thing we need to do is we only need to change the z alpha with our z alpha over 2. So this is we will get the equation for our n for this one. So now let me give one example of how we can do or how we can choose about a sample size for a one-side test. So in this example, we want to decide how many people we need to test, or in other words, what the sample size we need. For a hypothesis, the H0 is p equal 0.9, and H1 is p smaller than 0.9. And then for the given significant level alpha, or in other words, the probability of type 1 error is 0.05. And here, the true value of our proportion is 0.85, and then the accepted probability of type 2 error beta is equal 0.1. So for this one, the first thing is because this is a one-side test, so we should get about our z alpha. So here for this question, we will have our z alpha is z sub point, this question is 0.05. So when we use the table of standard normal distribution, we will get this answer is 1.64. So this is our value for z alpha. And then also by the table of standard normal distribution, we have this question for z beta is our z sub 0.1. This, the value is 1.18. So now the next thing is we only need to plug in these values into our formula of our n. So it will look like this. So we will have this equation. So here, please very, very careful about which is our value of p0 and which is our true value of the proportion p prime. So when we plug in all the value into our equation, then we will have, by the calculator, we will have the final answer of this one is 333.67. So now this is the value of our n, but the next thing is we always know n is a number for our sample size, right? But for sample size, what we can't do is we can't choose any number and a decimal number. So we can now say we select 0.67 person to join our surveys, right? So here what we should do is we should get an integer number for our sample size. So what we should do here, of course, this is two ways to do this. One is we use a round number. So here maybe if the first decimal number is smaller or equal to 4, we will ignore it. If it's larger than 5, we will round it to 1. But because for the question, this is something about the sample size to make sure our survey will get satisfy the significant level and the probability of beta. And when the number of the sample size is larger, we will always have smaller alpha and beta. So based on this property, what we have is we will always use a larger integer number for our decimal number. So that means for here, what the value of our n will be always a little larger than this decimal number. So it will be 334. So the final answer is 334 people we need to test or sample to get to satisfy this requirement. So now this is the end of our video, and please subscribe my videos and channels, and then next time when I publish a new video, you will get notification if you click the bell here. So see you in the next video.